Welcome back to Math with Mr. P. Today we're doing 6th grade math, chapter 4, lesson 3. We're multiplying fractions today. I'm not 1,000% sure why this lesson doesn't come before the other one, but we are multiplying fractions by fractions, and remember the number one rule, anytime you have a fraction and you're multiplying it, the other number should also be a fraction of some sort. Last time we learned that if it's a whole number, we just write that whole number over 1 and make it a fraction. During the preloading of chapter 4, I taught you that if you have a mixed number, you just convert it into an improper fraction by taking a whole number, multiplying it by the denominator, which would be 20, adding it to the numerator, which would be 21, and putting it over the other denominator, the same denominator, which is 21 over 20 over 2. This will come later, so don't worry about this right now. In this case, we're just going to have straight fractions multiplied by fractions. As always, when you multiply fractions, it'll be numerator times numerator and denominator times denominator. Once you're done multiplying, 1 times 1 will be 1, 2 times 3 will be 6. You check to make sure 1 is your fraction proper or improper. This is a proper fraction. And 2 is your proper fraction simplified, or if it is an improper fraction, you are going to need to simplify it. And in this case, it's already simplified, so my answer is 1/6. So there's not going to be a whole lot being taught today, not a lot of new concepts, but we're going to go ahead and go with the lesson anyway, because this will be a refresher for some of us. The real world link, excuse me, a chameleon's body is about 1/2 the length of its tongue, highlighted here in yellow, half the size of its tongue, not half an inch or half a foot, half the size of its tongue. Its tongue is 2/3 of a foot long, indicated right here, 2/3 of a foot. We are now trying to figure out how long the chameleon is. We are going to do 1/2 times 2/3, which is going to find out what half of 2/3 is. Remember, anytime you multiply by 1/2, you're actually trying to find out what half of that number is. For example, 1/2 times 4, half of 4 should be 2. Let's see if this works. 4 over 1, 1 times 4 will be 4. 2 times 1 will be 2. This is an improper fraction of 4 divided by 2. 2 will go into 4 twice. Now, when you have this, I don't say 2 and 0 2's. This is not a fraction. It's just 2. So my answer is 2. So anytime you multiply by 1/2, you're actually taking half of it. If you multiply by 1/4, you're actually taking a quarter of it, or a fourth of it. Multiply by 1/3, same idea. You're actually just taking that from it. So in this case, our lizard's tongue is 2/3. And I'm going to put in parentheses feet long, because remember, this is going to come back in the end to give us our answer. And we're going to go ahead and just erase this really quick. We're going to multiply this by 1/2 because the lizard, the chameleon, is half the size of its tongue. We're going to multiply right across. 2 times 1 will be 2. 3 times 2 will be 6. This is a proper fraction, however, it is not simplified. 2 and 6 both have a common factor of 2, which would make this 1/3. And this is where we're going to bring back the feet that we left in here, because it is measured in feet. So the chameleon is 1/3 of a foot long. And while I just circled 1/3 feet, I should have written out a sentence because it is a word problem. It deserves a word answer. So if we look here, it doesn't give us the answer, but that is the answer. The chameleon is 1/3 of a foot long. What it wants us to do is to shade the rectangle and do what we did in lesson 2. Something like this. I'm going to go ahead and skip that. Let's see. Let's just try it. Let's try it. Shade the rectangle that is 1/2 unit wide by 2/3 unit long. So, divide the rectangle into 2 rows, then divide it into 3 columns. My estimation rows are like this, and 3 columns would be like this. I'm going to go ahead and make the columns a little bit even. Shade rectangle that is 1/2 unit wide by 2/3 unit long. 1/2 unit wide, 2/3 unit long. That would be there. That's weird. It's 1/2 times 2/3. Yeah, I'm not a big fan of these ones. Because our answer again should have been 2/6. Oh, I know what they're saying. There we go. Let me explain this. Okay, now that I understand it, let me explain this. So this side here represents 1/2. One of these boxes is one of two because there's two boxes here. Over here, these are all divided into threes, or 2/3. What it wants us to do is to multiply 1/2 by 2/3. So, since this row over here represents 2/3, the 1/2, which would be this section here, going over 2/3, which would be this section here. This would represent 1, 2 out of 1, 2, 3, 4, 5, 6. 2/6, which we said was 1/3, which was our answer. That's a lot more complicated than just multiplying it the other way. But, I mean, if you can work the rectangle shading and if that works best for you, go for it. Again, you would definitely need to practice with knowing that it would have to be 2/3 and then 1/2, meaning that you would only shade this box for the 1/2 and only these two boxes for the 2/3, making this 2/6. And then simplifying it down. Multiply. So again, here they're doing another one. 2/5 times 1/2. Okay, 1 out of 2. 1, 2 out of 5. 1/2 times 2/5, when we shade it, would give me 2 out of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this would be 2/10. 2/10, if I divide by 2, since they both have a common factor of 2, would be 1/5. 1/5 would be my answer. This is how we show this with the rectangular shading. Now, if I wanted to do 1/2 times 2/5 the other way, I can. It would be set up as this, 1/2 times 2/5, and we multiply straight across. 1 times 2 would be 2. 2 times 5 would be 10. This is 2/10, which is what we had here. And then I'd simplify this by dividing by 2, which would give me 1/5. Now, I'm going to show you guys a different concept. So there is actually going to be something taught here different than what you've learned. This is going to be called cross simplification. Now, this is where you are going to look at the numbers that are diagonal from each other and see if they have a common factor. Now let me put the work that I just did here again so I can show you. This equaled 2/10, and then we simplified it down to 1/5. This was my answer. Now I'm going to use a completely different color. Let's use red for this one, and we'll use yellow as well. When I look for cross simplification, I look at the numbers that are diagonal from each other. So I'm going to look at one denominator and the other numerator. And the same thing here, one numerator, one denominator. These are the ones that are across from each other. 1 and 5 have nothing in common. This 1 pretty much says it's already simplified. So we're going to go ahead and ignore those, and I'm going to erase these little yellow lines. These 2, however, are the same number. If I divide them both by 2, because they have a common factor of 2, I can actually make these both into, I'm going to pick a different color, 1s. That's called cross simplification, where you can simplify numbers that are across from each other in a fraction. When I multiply now, 1 times 1 will give me 1. 1 times 5 will give me 5. That is still the same answer as I had up here. This is, again, is known as cross simplification. It is not needed. You do not need to cross simplify. So let me go ahead and put a little asterisk on this one. Cross simplification is not needed. Cross simplification is a tool to help you get your answer quicker and to have least amount of mistakes. This usually is going to work with bigger numbers. When you have way bigger numbers that you know have common factors and you can divide them up, that's when this will help. In this case, we could have still just multiplied across without these becoming ones. We could have left them 2, made it 2/10, and then divided by 2, and then made it 1/5. But it's something that I want to teach you just so that you have in your toolkit. This is not something that you need to use again. It's just something that is there and will help you, and I'll show you in future lessons when cross simplification will come in and be useful. So let's continue on. We're going to find 1/3 times 1/4. Write it in simplest form. 1/3, so using the rectangle method, 1/4. So you see they have 1, 2, 3, 4 boxes. We only get one of them. And then 1/3 also has 1, 2, 3 boxes. We only get one of them. So 1/3 times 1/4 would be this box here, which is 1 out of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. This will be 1/12, and that'll be my answer. You could do it the other way. 1/3 times 1/4, and this could be 1/4 times 1/3. Remember, because of the commutative property, the order doesn't matter. 1 times 1 will equal 1. 3 times 4 will equal 12. That is still the answer that I have up here. And then looking at my numbers, I didn't have to cross simplify at all because 1 and 4 didn't have anything in common and 3 and 1 didn't have anything in common. Let's do some of these got it's, and then let's see, simplifying before multiplying. We just went over that. So I did go over cross simplification, but we'll go over it one more time with the example that they give you. And then I think we're going to go ahead and solve these problems and call it a day. So let's do these got it's. 1/2 times 3/5. I like using the old-fashioned line them up and multiply. So 1/2 times 3/5. Using cross simplification, 1 and 5 have nothing in common, so they are simplified. And then on the other side, 3 and 2 have nothing in common, so they are already simplified. So there's nothing we can do here to simplify it any further. We just need to multiply straight across. This will give me 3/10. Because 1 times 3 is 3, 2 times 5 is 10. 3 and 10 have no common factors whatsoever. So that's my answer. 1/2 times 3/5 is 3/10. 1/3 times 3/4. 1/3 times 3/4. Now, using cross simplification, I can easily make these two 3's 1 because they're the exact same number. Let's go ahead and use simplification here, and then I'm going to use the regular method to show you how to do this without doing this. 1 times 1 will be 1. 1 times 4 will be 4. My answer is 1/4. Now, without cross simplification, let's plug the 3's back in. 1 times 3 would actually be 3. 3 times 4 would be 12. And both of these have common factors of 3, so when I divide by 3, it becomes 1/4. So, you can cross simplify these early, make them 1's, and then you save yourself another step over here, or just multiply straight across and then divide by the common factor later. Either way, the answer is right. The answer is 1/4. And our last example for this round, 2/3 times 5/6. 2/3 times 5/6. Now, there is a cross simplification here. 3 and 5 do not have any common factors, so we're not being able to simplify there. But 2 and 6 do. They both have 2 in common. If I divide 2 by 2, it becomes 1. And if I divide 6 by 2, it becomes 3. This will now become 5 over 9. And that has no common factors whatsoever. We're locked in. Let's do this without simplifying. Let's plug in the original numbers. They were 2 and 6. If I multiply 2 times 5, that'll give me 10. If I multiply 3 times 6, that'll give me 18. These both have 2 in common. When I divide them both by 2, 10 divided by 2 will give me 5. 18 divided by 2 will give me 9. The exact same answer as I had over here. So you can use cross simplification, or you can just go through it and then divide by a common factor later. It's completely up to you. So let's look at the example they give us for cross simplification. If the numerators and the denominators have a common factor, you can simplify before you multiply. Remember that factors are 2 or more numbers that are multiplied together to form a product. So the example they give us is 2/3 times 5/6. That's the one we just did. So let's walk it over again. 2/3 times 5/6. So again, we check the denominator and the numerator of the opposite ones. 5 and 3 have nothing in common, no common factors, so I'm going to go ahead and erase the bubble. But 2 and 6 do have common factors. 2 can go into both 2 and 6. So I'm going to divide both of these numbers by 2. When I divide 2 by 2, it becomes 1. When I divide 6 by 2, it becomes 3. I have simplified before I have multiplied now. That is called cross simplification. Now I can multiply straight across. This will give me 5/9. And then one more time, without the simplification, if I were to multiply these numbers originally, 2 times 5 would give me 10. 3 times 6 would give me 18. This is not simplified. Divide by 2, because they both have 2 in common. That would give me 5/9. 10 divided by 2 being 5. 18 divided by 2 being 9. The exact same answer I got when I did simplify before I multiplied. So that is the definition of cross simplification. So let's go ahead and do these examples. 3/4 times 5/6. 3/4 times 5/6. The 3 and the 6 have something in common. The 5 and the 4 do not. So I'm going to go ahead and erase that. 3 and 6 both have common factors of 3. 3 divided by 3 will become 1. 6 divided by 3 will become 2. I can now multiply straight across. 1 times 5 will give me 5. 4 times 2 will give me 8. And my answer is 5/8. Doing it the non-simplified way, so plugging back in our original numbers, 3 times 5 would give me 15. 4 times 6 would give me 24. Both have a common factor of 3, which would give me 15 divided by 3 is 5. 24 divided by 3 is 8. Still gives me the same answer that I had before. And our other example is 4/9 times 18. 4/9 times 18, and of course, all whole numbers should be thrown over 1. Now, that 1 is going to indicate that these two have nothing in common. Remember, if any of your numbers is 1, the opposite will not be simplified anymore because it's 1. You can't simplify 1. However, this 18 and this 9 do have common factors. This is where it becomes really helpful to cross simplify, because otherwise I would need to multiply straight across, and 18 times 4 is going to be a lot of more work than just doing 18 times or 4 times 2, because if I divide it by 9 that would become 2. So let's do this the long way. 18 times 4. 4 times 8. Again, I'm not great with my 8, so this is where I'm going to use my mental math. I know that 8 times 3 is 24. If I add 8 more to it, it's going to be 32. And that's how I can remember my 8s, because I am terrible at my 8s. 4 times 1 will be 4, plus the 3 will be 7. So this will equal 72 on this side, and 9 times 1 will be 9. Yay, 72 over 9. I'm going to divide these both by 9, which will give me 1 on the bottom. And I know 8 times 9 is 72, so this will be 8 over 1, or just 8 as my answer. That was without cross simplification. And remember, I had all the work here for 4 times 18. Now, let's solve this with cross simplification. 9 and 18 both have a common factor of 9. If I divide 9 by 9, I will get 1. If I divide 18 by 9, I will get 2. 4 times 2 will give me 8. 1 times 1 will give me 1, which is what I had here. 8 over 1 is just known as 8. And there's my answer. So this is a really good example of why cross simplification comes in handy, because this is a lot more work than having to do 4 times 18, then divide that product by 9, and so on. Cross simplification can be your friend. It is not necessary. It's not needed, but it can make a really difficult problem a lot easier. So something to keep in mind. And let's look at our examples. And this will wrap up this. So go ahead, as always. I did not want to draw that, but okay. Gotta love OneNote. Go ahead and pause the video and see if you can multiply all 3 of these problems and solve them. And I'm going to challenge you to use cross simplification here, because once I solve these on this video, I am going to do this using cross simplification. I'm not going to solve this the regular way. So go ahead and pause this and see if you can cross simplify any, and then see what the answers are. All right, hopefully you did pause the video and you're coming back. So let's do D, 3/4 times 4/9. 3/4 times 4/9. In this case, and I'm going to change the colors up a little bit. Let's do that green and that yellowish orange. 3 and 9 are both going to have factors, and then 4 and 4 are the same number. So I'm going to rewrite this problem over here. 3 and 9 both have 3 in common. If I divide 3 by 3, that's going to become 1. And if I divide 9 by 3, it's going to become 3. So I cross simplified those two. And then over here, 4 and 4, we're just dividing them both by 4, which means they will both become 1. This becomes a lot easier than having to multiply 3 by 4 and then 4 by 9 and then having to find common factors. Now I'm just going to multiply 1 times 1, which will give me 1, and 1 times 3, which will give me 3, and my answer is 1/3. So a lot easier than having to do it the other way. This is going to be the only example. I know I said I wasn't going to do it the old-fashioned way, but this is going to be the only example that I show you guys what would happen. 3 times 4 would be 12. 4 times 9, as we all know, is 36. These both would have 12 in common. You could have said 3, 6, whatever. You would have had extra steps, but they actually both have 12 in common, which would make this 1/3. 12 divided by 12 is 1. 36 divided by 12 is 3. Same answers up here. If you didn't know that these had common factors of 12 and you divided by, say, 3 or 6, there would have been extra steps. So a lot easier just cross-simplifying as such. Next example. We have 5/6 times 9/10. 5/6 times 9/10. And we are going to have to rewrite this problem completely because 5 and 10 have common factors and 9 and 6 both have common factors. 5 and 10 both have 5 in common. which will make this 1 and make this 2. And 6 and 9 both have 3 in common, which will make this 2 and make this 3. Again, we divide by the numbers they have in common. 5 divided by 5 would be 1, which is why I put 1 here. 10 divided by 5 will be 2. 6 divided by 3 will be 2, because 6 and 9 both have 3 in common. And 9 divided by 3 is 3. So my new problem would be 1/2 times 3 over 2, which would give me 3/4. 1 times 3 is 3, 2 times 2 is 4. My answer is 3/4. A lot easier when we use cross simplification, because otherwise this would have been 45 over 60, and then you can have fun finding common factors with that. You divide by, I'm assuming 5 first would be the first one to come to mind, and then you'd keep going. I, on the other hand, would just do cross simplification to solve that problem. And our last example for this video, 3/5 times 10. 3 over 5 times 10, which would become 10 over 1, as we learned last lesson. 3 and 1 will have nothing in common, but 10 and 5 will have 5 in common. 5 divided by 5 will become 1. 10 divided by 5 will become 2. Multiply straight across. This will be 3 times 2 will be 6. 1 times 1 will be 1. Anytime you have an improper fraction like this where it's over 1, 6 divided by 1 will just equal 6. And my answer is 6. So, as always, that's pretty much it for this lesson. I think the new concept that we were taught was how to cross-simplify. Please make sure you practice that. Again, not necessary. You do not need to use it. I will say this, it is definitely one heck of a tool to have in your math toolbox that will make your life easier. It will make questions a lot faster, and it'll make it easier to not make any mistakes, because otherwise you'll be dividing other fractions, simplifying them down. So cross simplification is something to practice. If you have any questions at all, as normal, message me on Teams if you're in my class, and if you're not in my class, please leave a comment down below and I can get to you as soon as possible. As always, I'm Mr. P, and I will catch you guys on the next one.